Welcome back. Today we're working on 14D, which is rational numbers. Our content objective is students will be able to convert and simplify rational numbers. Language objective is students will be able to describe the difference between rational and irrational numbers. And why am I learning this? Well, it's important for solving real-world problems like calculating percentages. So let's first talk about rational numbers. What are they? Well, it's basically any number that can be written as a ratio of two integers, what we know as a fraction. So 6/10 is a rational number, -5 is a rational number, and 2/3 is a rational number. Why, you might ask? Well, because all of these numbers could be rewritten as a fraction. 6/10 could be expressed as 3/5, -5 could be expressed as -5/1, and well, 2/3 is already a fraction, so of course you can write it as a fraction. So some types of rational numbers will include terminating decimals. Basically, this is when you're converting a fraction to a decimal and you notice that the decimal actually stops. So here's an example of one. 625 thousandths is rational. Why? Because I can express it as a fraction. So repeating decimals is another type of a rational number. It's basically when you're converting a fraction to a decimal, the decimal repeats. So here, 0.16 repeating on the 6 is rational because I can express this value as a fraction. So remember, anything that can be expressed as a fraction is a rational number. So what happens if you can't express the value as a fraction? Then it is irrational. So by definition, it's any number that cannot be written as a ratio of two integers, aka a fraction. So the square root of 5 is irrational, pi is irrational, and 0.132456629 ... is irrational. So you might be wondering why. Well, let's take a look at the square root of 5. You'll notice here the square root of 5 is approximately all of this, and in fact it goes on forever. It doesn't stop. You'll notice there is no terminating decimal, obviously, and it's definitely not repeating. So there is no way I'm able to express this value as a fraction. Therefore, it is irrational. And what about pi? Well, pi does not stop. It's 3.14 and so on. So again, we can express it as a fraction. Therefore, it's irrational. And this number, because it doesn't stop, is also irrational because I am unable to express it as a fraction. Okay, so real quick, please don't think that the square root of any number will be irrational, because the square root of 49 is 7, and that would be rational. Why? Because I can express 7 as a fraction. I just put 7/1. So remember, by definition, a number is rational if you can write it as a fraction, and a number is irrational if you cannot write it as a fraction. So today our focus is going to be more on rational numbers. So let's first start with conversions. Okay, we're going to first convert fractions to decimals that are terminating. So here, if we're given 3/8, what does this mean? Well, it means 3 divided by 8, so that's exactly what I'm going to do. First, before I do anything, I want to bring up that decimal. Can 8 go into 3? No. Can 8 go into 30? Yes, 3 times 24, leaving me with the remainder of 6. And bring on the 0. 8 goes into 67 times, which gives me 56, with a remainder of 4. Now we got to bring down this other 0. 8 goes into 40 exactly 5 times, so I'm going to go ahead and say 3/8 from written as a fraction can be expressed in a decimal form as 375 thousandths. Now, what if I asked you to go backwards? Which means, what if I wanted you to start with a decimal and turn it into a fraction? Now, what would you do? Well, first you're going to have to read it correctly. Here, I would read that as 375 thousandths. And simply by reading it correctly, I'm able to figure out how to write it as a fraction. Again, I said 375 thousandths. And there you have it. Now, one thing you have to be very careful about is you always want to make sure your fractions are reduced. So unfortunately, this isn't reduced, so I'm going to have to reduce it. I'm going to go ahead and divide the numerator and denominator by 125, and that's going to leave me with 3/8. So notice it's the same value no matter which direction you go. okay? If you don't get the same answer, then you might have done something wrong. Okay, so now let's try another example, except in this case, let's see what happens when the decimal is repeating. So here we have 5 11ths. This means 5 divided by 11. So I'm going to go ahead and divide. First, bring on that decimal. Can 11 go into 5? Nope. Can 11 go into 50? Yes, it can go 4 times with a remainder of 6. Bring on the 0. Whoops. Bring on the 0. 11 can go into 65 times with a remainder of 5. Bring down the 0. 11 can go into 50 4 times with a remainder of 6. Something looks interesting here. 11 is going to go into 65 times, which is 55 with the remainder of 5, and bring on the last 0. So hopefully by this point, you're starting to recognize a pattern. You're starting to recognize that this is going to start over and over and over. So let's think, what is repeating and how should we write it? Well, should you write it as 0.454 repeating on the 454? No, because that would mean 454 is repeating. So the other digits would then be 454, 454, and that's definitely not the pattern. Is it 0.45 repeating on the 54? Technically, it would mean the 54 is repeating, and that again is not the value. What about 0.45 repeating on the 45? The answer is yes, because that's exactly what's being repeated. So please make sure the placement of your bar is over the digits that are repeating. Okay, so real quick, let's talk about what would you do if you were converting 5 and 7 11ths, 7 12ths. Well, what I would do is I would convert this into a decimal and then just tack on 5 in front. So if this was a 5 and 5 11ths, I would just put 5 and 5 11ths afterwards. So there's no reason in incorporating the whole number. Just save it till when you're finished dividing and set it as an actual whole number. Okay, so when we're converting repeating decimals to fractions, most of it can be done mentally through using a pattern. So 0.1 repeating on the 1 is 1/9. 0.2 repeating on 2 is 2/9. 0.3 repeating on 3 is 3/9, which could be reduced to 1/3. 0.4 repeating on the 4 is, you guessed it, 4/9. And 0.5 repeating on 5 is yet again 5/9. So hopefully you're starting to see a pattern here. Okay, what if I ask you 0.6 repeating on the 6? Hopefully you say 6/9, which then can be reduced to 2/3. 0.7 repeating on the 7 would be 7/9. 0.8 repeating on the 8 is 8/9. And 0.9 repeating on the 9 is 9/9, which is essentially 1. Now, real quick, I do want to talk about that. What this means, it's 0.9999999, goes on forever, it doesn't stop, which technically is just getting round to 1, okay, because it's very close. 0.13 repeating on the 13 is 13/99. 0.25 repeating on 25 is 25/99. 0.128 repeating on the 128 is 128/999. And here, what do you think? 0.3462 repeating on the 3462, what would that be? If you guess 3,462/9,999, you are correct. Now, what about 0.64 repeating on the 4? Now, it's not going to follow the pattern that you've been recognizing in the previous ones, because here, the entire, let's say, all of the digits after the decimals are repeating, and that's why we're able to use that pattern. But you'll notice here, not every single digit's being repeated here, so you can't say, oh, this is 64/99. That would be incorrect. It's a little bit more difficult to do. Okay, so let's go ahead and figure out how you would do that. So here it says convert 0.64 repeating on the 4 to a fraction. First, what you're going to want to do is go ahead and let x equal the number. Once you've done that, what you're going to do is identify the furthest digit that's being repeated. In this case, the furthest digit is the tenths hundredths place. So because it's in the hundredths place, I'm going to go ahead and multiply by 100. By doing that, x times 100 is 100x. And here, multiplying this digit by 100, it's going to move my decimal over 2 places to the right. Now notice it's going to be 64, but isn't the 4 supposed to still be repeating? The answer is yes. So that's why I wrote it as 64.4, and the 4 is still repeating, so that's not going to stop. Now once you figured out which digit is repeating, what you're going to want to do is then figure out what's the furthest digit that is not repeating. So in this case, it's going to be the tenths. So I'm going to go ahead and multiply both sides by 10 now. So x times 10 is 10x, and here it's going to move my decimal over once to 6.4, repeating on the 4. So now once we have that, what we can do is use elimination. Okay, what we're trying to do is to eliminate the repeating 4s. So here I'm going to go ahead and multiply the bottom by a negative. So the first one's going to stay the same, but the bottom one is going to be multiplied by a negative. Why did I choose to make the bottom equation a negative? Because by doing this, it's going to allow my answer to be, it's going to allow me to work with positive numbers versus negative numbers. Okay, so I'm going to make sure I'm lining up those decimals. And once I've done that, 100x minus 10x is 90x. And here you're going to see that the repeating 4s are going to basically cancel each other out. And I'm going to be left with 64 minus 6, which is just 58. Now what you're going to have to do is divide both sides by 90, and you're left with x equals 29 over 45, because I went ahead and divided both the numerator and denominator by 2. And then there is your answer. So this number expressed as a fraction would be 29 over 45. So obviously this is rational because I can write it as a fraction. Okay, so real quick before I have you try one on your own, let's real quick talk about some divisibility rules, because you're going to find in this lesson you're going to have to divide some pretty large numbers. So of course something is divisible by 2 if it's even, which means it ends in a 0, 2, 4, 6, or 8. So here's an example of one. I know it's even just by the last digit. It's an even number, so I'm going to say that this is definitely divisible by 2. A number is divisible by 5 if the last digit is divisible by 5. So here 0 is divisible by 5. 0 divided by 5 is 0. So that's why this number is divisible by 5. A number is divisible by 4 if the last 2 digits are divisible by 4. So here is 24 divisible by 4. The answer is yes. So this entire number is divisible by 4. Now what about 3? 3 is a cool one. It's divisible by 3 if you add all the digits, and that number is divisible by 3. So for example, if I add 1 plus 4 plus 1, that gives me 6. Is 6 divisible by 3? Yes, then this entire number is divisible by 3 as well. Divisible by 9 is the same thing as divisible by 3, except you're checking to see if it's divisible by 9. So here, if I add 2 plus 8 plus 9, that's going to give me 19. So unfortunately, this one's not divisible by 9. But real quick, what could I do to fix that? Well, if I made this 9 and 8, okay, then it would be divisible by 9 because 2 plus 8 is 10, 8 plus 8 is 18. So things like that. And the last one I want to talk about is divisible by 6. If your number is divisible by 2, which means it is even, and it's divisible by 3 because all the digits add up to a number that's divisible by 3, then it will be divisible by 6. So real quick, let's check. It's even, so it's divisible by 2. Is it divisible by 3? Let's see. 5 plus 5 is 10 plus 8 is 18. 18 is divisible by 3, so since it's divisible by both 2 and 3, it's divisible by 6. So I want you to practice those because it will come in handy when you're trying to reduce fractions that have fairly large numerators and denominators. Okay, so at this point, let's go ahead and try number 4 on our own. Okay, let's see how well we did. First, you have to decide which digit is repeating. In this case, it is the hundredths. So you're going to multiply both sides by 100, leaving you with 100x equals 23.3 repeating on 3. If you're wondering how I got that, I'm going to move my decimal over 2 places. It is a repeating 3, so I know that there's more threes after, and that's why I put 23.3. Okay, well, then you have to determine the furthest digit that's not repeating. This is going to be the tenths place. So I'm going to go ahead and multiply both sides by 10, and that's how I ended up with 10x equals 2.3 because you move that decimal over just once. Now we're going to try to eliminate the repeating 3, so I'm going to multiply the second by a -1. I'm keeping the first one the same. I like to line up the decimals, of course, whenever we're adding and subtracting. The 100x minus 10x is 90x, and here the repeating 3's cancel each other out. 23 minus 2 is 21. Now you just need to divide both sides by 90, and here you want to see if you can reduce. 21 and 90 both have a 3 in common, so that's going to leave me with 7 over 30. And real quick, you know 21 is divisible by 3, but you can test it out. 2 plus 1 is 3. Is 3 divisible by 3? Yes. And again, you know 90 is divisible by 3, but if you wanted to just practice, 9 plus 0 is 9. 9 is definitely divisible by 3. So hopefully you got that one right. Now let's move on to something a little bit different, but very similar. So we're asked to convert this number into a fraction. So here, first, you want to determine what is the digit that's repeating for this digit. This is the 10 hundredths thousand. So this time I want to multiply by the thousandths place, leaving me with 1000x equals 185.5. So real quick, 1, 2, 3. That's how I got 185. And of course, the 5s are still repeating. Then you want to look at the number that's not repeating. You want to look at the furthest digit. And this is the 10 to hundredths place. So now I'm going to multiply by the hundredths, leaving me with 100x equals 18.5. So real quick, if you wanted to see, move your decimal 2 places. And that's how you get 18.5, repeating on the 5. Once you've done that, we're going to try to eliminate the repeating 5s. So you're going to have to, first of all, keep the first equation the same, but multiply the second one by a -1. Once you've got that, making sure your decimals are lined up, you'll see here that you're going to end up with 900x. And here the 0.5 repeatings will basically eliminate each other, leaving us with 900x equals 167. Now just divide both sides by 900, and you're left with x equals 167 over 900. Now here's what I was trying to mention. Your numbers are going to be rather large, and you need to be able to check if your fractions can reduce. So quickly, I always check, are both numbers even? Nope, that means 2, you can't divide by 2. Can I divide by 4? Well, the last 2 digits here aren't divisible by 4, so that's not going to work. Definitely not divisible by 5. Is it divisible by 3? Well, let's see. 1 plus 6 is 7. 7 plus 7 is 14. Nope, 14 is not divisible by 3 or 9. So right now, I've checked all the numbers that I could check with the divisibility rules, and I don't think there are any other numbers I can check, so I'm going to go ahead and say that this is my final answer. So with that, go ahead and try number 6 on your own and see how well you do. Okay, so first for number 6, hopefully you went ahead and multiplied by 1,000 first because the 2 is in the thousands place. This is what you should have ended up with. And then you had to go to the digit that's not repeating, and the first one would be the hundredths. So the next one would be multiplied by 100. Then you're going to want to try to eliminate, so you're going to have to keep the first equation the same and then multiply the second one by -1. Making sure I line up my decimals, I'm going to end up with, well, first this is going to cancel out. And I'm left with 900x equals 335. Simply divide both sides by 900, and you're left with x equals 335 over 900. Real quick, at first glance, I can see right away it's divisible by 5 because the last two digits are divisible by 5. So once I do that, I'm going to end up with 67 over 180. Now, you still want to check if this answer can still be reduced. Can't be reduced by 2, cannot be reduced by 3 because 6 plus 7 is 13, so 9 won't work either. So that's about it. I'm going to say that's my answer. Okay, so here, let's go ahead and work on completing this table. It says we're given a table and we want to go ahead and convert the decimal into a fraction. So here, the tenths hundredths place is repeating, so we're going to multiply by 100 to both sides. The digit that's not repeating is the tenths, so we're going to multiply both sides by 10, leaving me with 90 over 90x equals 19. Divide both sides by 90, and I'm going to get 19 over 90. Number 8, here. Go ahead and pause the video and try this one by yourself. So real quick, the 5 is the repeating decimal, so that's in the hundredths place, so you're going to divide both by 100 first. The digit that's not repeating is the tenths place, so I'm going to go ahead and multiply both sides by 10. So here, notice I went ahead and saved myself that step and made sure to multiply the entire bottom equation by a negative because I knew that I was going to try to eliminate the repeating decimal. So here I'm left with 90x equals 41. Divide both sides by 90, and I'm left with 41 over 90. Now notice I'm stopping because I do recognize that I cannot reduce them. Number 9, here, the digits that's repeating is, the furthest one is the tens, hundreds, thousands, so I'm going to go ahead and put the thousands place. So multiplying both sides by 1,000, I'm left with 1,000x equals 123.23. And it should be repeating on the 2, 3. Let's put that in there. And then the digit that's not repeating, the furthest one, is the tenths place. So we're going to multiply both sides by 10, saving myself that extra step and also multiplying by that negative. So here you're going to, let's also include that repeating 2, 3. These will cancel out, leaving me with 990x equals 112. Divide both sides by 990. I would get this fraction, but it can be reduced by 2 since both of these digits are even. So my answer is 61 over 495. Here, what's the farthest digit that's repeating? It's going to be the thousand, so you're going to multiply both by 1,000. Let's not forget our repeating. And here, the furthest digit that's not repeating is the hundred, so you're going to multiply both sides by 100. Make sure you don't forget to write in that repeating. Now here, you're just going to go ahead and eliminate the repeating decimals. You're left with 900 equals 25. Divide both sides by 900. Here, I can divide both by 25, so that does leave me with 1 over 36. So for the last one, what do we do here? There's technically 2 options. I'm going to go ahead and first show you the most basic option that follows the patterns like the rest. You're going to first decide, okay, tens, hundred, thousand is going to multiply both by 1,000. And then here, the furthest digit that's not repeating is the hundreds, multiply both by 100, including that negative number so that we can go ahead and eliminate the repeating decimals. Let's add that in because it is missing. So here we're going to see that the repeating ones are going to reduce, leaving me with 900x equals 3,691. So here you would divide both sides by 900, and when you do the division, you will end up with 4 and 91 over 900. Now, if you didn't want to do that, This is 4 and 1, 0, 1 repeating on the 1. So if you wanted to, you can ignore the 4 for a second, convert this into a fraction, then, which would have given you this. And then once you finish that, you can bring the 4 back in and just add it back as a whole number. So whatever you feel you're more comfortable with, it doesn't matter. You will get the same answer, no matter which way you do it between the two. So that is going to conclude the lesson for today. Thank you so much for tuning in. And as always, until next time, bye.